Greetings, everybody. This is Eric Andelin with SimActive, and you are joining us for our webinar on Correlator3D version 9.2. 9.2 has some great enhancements in it, and most important is the ability to bring in phase one IIQ imagery, which we're really excited about. So I'd like to start by introducing myself. Again, Eric Andelin, Senior Workflow Specialist with SimActive. I also have on with me guest speaker Will Tompkinson with Phase One. Will, say hi.
Hi, everybody. Thanks for having me.
Very good. And I also have one of our photogrammetry specialists, Thomas Barucci, on the line. Thomas, say hi.
Hi, Eric. Hi, Will, and hi, everyone. Very glad to be here today with you.
Great, great. So everybody knows, so this webinar will also be turned into a podcast at some point later on. And part of that is that, we're doing this webinar. We do see your questions. We'll answer your questions when we get to them. If not during the webinar, then certainly after the webinar. I got to say, I'm really excited to have Will on the line with me. We have a lot more in common besides our love of photogrammetry. We have worked together or as peers in the past, and we also have a very good, fond love of cycling. If anybody happens to be coming to the Commercial UAV Expo, probably Will and I will be doing a ride. If you want to join in, just let us know in the messaging. If you're going to be there, it'll be on my birthday, September 7th. So it'll be awfully early, like 5 a.m. because it's Vegas. But we always have a good time. We always chat work, chat business. This is where I learn most of the stuff that I learn about phase one and what's coming up. So this actually led to the conversation about IIQ format and where we go and how we could integrate this. So that's really cool. I brought that information back to our development team. And those guys, hopped right on it once the SDK was available. So let's start with that. Will, tell us a little bit about phase one, the history of phase one.
Phase one have been around since 1993. We are a medium format digital aerial imaging leader. They put it out of Copenhagen. We have worldwide operations. We have services and calibration facilities in Israel, Japan, and North America, sales offices across the world. We work with customers in so many industries because it's not just aerial cameras which we manufacture, but that's obviously the division which I work in, phase one geospatial. And we've had a real evolution of phase one's aerial camera technology since approximately 2012. There's been a continuous advancement. I personally manage our integration division across the Americas. So if you are if you're building a mapping solution, as we know, mapping solutions are quite complex systems. If you're using phase one components in that, it's likely you'll be speaking with me.
That's great. And the reality is, and I've been with SimActive for a few years now. I've always been a SimActive user, so it was easy for me to come on board as a workflow specialist. But the trends that I see going on here, phase one with their cameras has really, really moved into a great spot. And it all comes down to a quality camera, and especially for mapping, a quality camera means that it's a calibrated camera, it's a metric camera, and by that I mean atmospheric conditions don't change the parameters of the camera, temperature, none of those things affect the camera. So the slightest little change in a camera based on the body, based on the quality of the lens, those things affect a mapping product. And until phase one came along, there really was nothing that was of that caliber. And I know, again, on your website, it mentions bespoke photography and all of that. In reality, it was a film industry camera. I mean, it was a hardcore quality camera before it became a mapping camera. But the opportunity was there, the market was there, the intelligence was there from the team to put together this camera, or these cameras, these sensors, And the only thing I can say, the only thing I want to add to that is, where is my invite to Copenhagen? Because I really need to go ride there again. That's always a fun place. But we talk about the drone world a lot, which is great. And Phase One makes cameras for drones. They're fantastic cameras. But there's also a leap into the mid format market, which, maybe you can't afford a large scale professional mapping camera like a ZI or something like that, because they're really, really expensive and they're really big, and the format is great. But there's a whole world of mid format that's fantastic. And I really think it's opening up aerial photography and photogrammetry into an area where currently there's a great need. So let's talk, a little bit about each different type of sensor you guys have.
Yeah, so obviously the cameras are what we're known for, and we essentially have a range of medium format digital cameras which start at 100 megapixels and go up to 280 megapixels. Um, typically an airborne customer flying a camera with something like a lidar system might be using a 150 megapixel camera with like a 50 mil lens. But obviously we have lenses which suit a variety of application contexts. And I should probably note that those lenses are made by us in house to ensure the quality is where it needs to be. And that same camera platform, so as I say, is used by integrators for integrating with other mapping systems such as lidar systems. It's also the same camera which is used by our inspection communities, which we serve from the UAV platforms with the P3 product, a completely integrated solution for working with DJI platforms and the other main platforms in the industry. And then now also we've got a range of fully integrated aerial photography systems, our PAS systems, which range from systems which are collecting 150 megapixel imagery through to 280 megapixel imagery, all the way up to our 880. So that's a 280 megapixel sensor with achromatic 150 megapixel imagery plus 450 megapixel RGB cameras collecting both nadir and oblique imagery all at the same time. And all these systems, obviously are underpinned by integrations we have with our partners. So, for example, industry leaders such as the Planets and SOMAG. It's all wrapped around with a full flight planning, image capture, and post-processing quality assurance workflow, which is wrapped around with our IX suite of software. And what all of our intention is with all of our camera solutions is that we're delivering data which you've been able to not only do you have confidence you're working with calibrated imagery, you're working with imagery which we're using sensors which have large dynamic ranges on. So what it means is that you're able to increase the day in which we're able to work. It also the full frame, which means that from a higher altitude you're still able to maintain GSD, which also means that you can work with a larger field of view across each image set you're collecting, and so across all of our platforms that leads to production efficiency. And then with regards to sort of wrapping that up into these fully integrated systems with a full software workflow around them, means that what you're outputting from the system is something you can depend upon as well. And that's really the crux of where a lot of our values are. We're not just in the aero market, but across all the other markets as well, which we serve. We're supplying very professional imaging solutions.
Very good, very good.
Yeah.
I always go ahead.
I was going to say our partnerships with with the software workflows such as those with SimActive, based upon the IIQ format, which we're going to talk about today, just further dramatically extends the extent to which we're able to deliver data, which our customers can depend upon.
Well, you're very good, and you caught me there for a second. I always get ahead of myself when I do these webinars, and the one thing I wanted to hit before we keep going is we've got a slide. You may have seen it. It's just what you're going to learn in this webinar, or at least the topics we should hit at some point. And that's choosing the right phase one imaging sensor, understanding what intelligent image quality IIQ format is. In our case, determining when to use IIQ. And then also, as I said, Thomas and I will get into actually processing an IIQ. How do you set up projects and how do you process it? As we talk, things come to mind. And again, there's another slide up here that talks about, phase one over the decades. And you can see originally it's a sensor. And as you slide down that scale, we get to, like you said, the past systems, which to me start to look like aerial photography systems. They start to look like what you drop in the belly of the aircraft. And that is an integrated system. And I'm doing a blog post as well here pretty soon. I'm working on that talks about system integration. You can have one great component, but if the rest aren't great, you're not going to get the best solution ever. And in this case, my blog post is about PPK and RTK. A component of that is camera's got to be a calibrated camera. You also need a quality GPS antenna, airborne GPS solution, whether it's PPK or RTK. With that, you have to have a very, very good IMU. All three of those things as part of that system integration give you what we see in a past system, along with the software that Will is talking about. With all that, you can get some absolutely fine data. But to me, as a photogrammetrist, the most important thing is the camera. We were doing photogrammetry long before GPS, long before IMUs. Photogrammetry solves all those other issues. The challenge in the drone world I see is that you're limited to your 400 feet, which means that if you're going to map a certain area, your footprint is so small that you can't do traditional photogrammetry with it. In other words, you can't set up models. Well, you can, but transferring between model to model to model in a solution that's that small is very, very cumbersome and annoying when you're doing it, which is great for us in the software world because our software does that without stereo models. But once you get into the medium format, once you get into the phase one sensors, then you are flying at a much higher altitude. That higher altitude with the single cameras, with the dual cameras the images are merged together, creates a much larger footprint. That much larger footprint creates fewer models, which means you can work more on those models for moving to the next one, and photogrammetry from stereo becomes very feasible again. So something to think about. But this is just me talking. So Will, agree, disagree? Where are you at on this?
But very, very much so. And the extent to which you can use a photogrammetry film at a high resolution to collect high detailed dependable data had really evolved dramatically, even I'd say even within the last 5 years. So you mentioned the drone community there. When we first started doing drone photography, there was a great trend to put a point and shoot camera, a non-metric point and shoot camera onto a drone platform because you always have limitations in terms of platform weight and all that sort of business. The intent is to actually we familiarize ourselves with photogrammetric techniques which perhaps we started with airborne photogrammetry 20 years ago. And from a access to market and that sort of thing, those types of solutions really helped. But now we're realizing that actually, hey, you can put a high resolution sensor on your drone platform. You can actually use a metric sensor. Even though you've got all the other limitations that you have in terms of flight height and all the restrictions, etc., etc. You're able to still produce a very full, dependable photogrammetric based product to your end clients for what they're looking to use it for. So we're seeing this increasing range of photogrammetric products that just further builds on this great history we've got. As I say, we've been doing photogrammetry before GPS. In the survey mapping community, the availability of dependable products, whether or not they're the cameras or the software processes or the techniques which we're applying to it, really has really expanded.
Yeah, that definitely true. And like you say, now that we have metric cameras even down into the drone space, you are going to get a better solution off the bat with those. And maybe combined with PPK and enough research on your own end with the software, the solution, the camera, you may get to the point where you can reduce the amount of control you need over the the entirety of your project, or the number of checkpoints, however you want to do it. But it it makes life easier for the software on the processing side, maybe on the survey side for yourself. You'll see that with these metric cameras, with the phase one cameras, and I got to tell you, I'm excited about them. Even from the drone space to the medium format space, I have seen data come in. Again, with the right sensor combination, where there's almost no adjustment to the XYZ position or the omega phi kappa, with the right IMU, and it just is dead on. And that's so exciting to see again these days. So I'm really happy about that. Again, the software doesn't have to do as much adjustment, and you're going to get a much better result. The next big step here, and the reason we started working with you guys SDK, is the intelligent image quality format. So tell us a little bit about this.
So IIQ, our intelligent image quality format, is a raw format which we've been using for many years. I mean, almost a year. It is a proprietary format, and it's in our world it's an uncompressed format, but it's one that we've designed so that it preserves the aspects of the image which you want to be able to work with most efficiently in your onward workflow. So, for example, it's a completely lossless format, even though it's in our view, an uncompressed format. It's a format which reduces what might be a traditional raw image by 50%. So what we're doing is maintaining the best image quality and enabling you to access those characteristics of the image in a way which is further optimized in terms of the extent that you have to move large image sizes around. The images take up space, and if you're able to show the best characteristics of the image at a lower file size, it's going to help the entire workflow that you're working with.
We've got a slide up that shows some of this, but let's go back real quick. Raw format's been around for a while, or at least the idea of raw format. Raw basically just means you're capturing the image from the sensor, and you're keeping everything. You're not adjusting for anything. You can do that in post if you want to. So your low light levels, your highlight levels, all those things. People will know in the past, if in a traditional JPEG image, if you set your white balance incorrectly or something like that, you may have blown out rooftops and things like that, because that's hard coded into the image when you capture it. Whereas what you guys are talking about in a raw format, correct me if I'm wrong, because I am not a professional photographer, you're saving all of those parameters so that you can adjust them in post. Is that correct?
You are.
Okay.
You are. And so I guess, in the real world, things I'm talking about are the fact that, if something is in shadow, which when we're looking from the air, since that happens often, right? You're always planning emissions for, relative to daytime, relative to what time of day it is and that sort of thing. But you will always have shadow in your image. How can you see what that feature is in that shadow? Well, you do that by exploiting the radiometric resolution of the image. And how can you have access to that? Well, you keep the image in as unmutated format as possible. So you're really exploiting what the sensor is giving you. And as I say, for our IIQ format, we are providing a format where we have preserved the characteristics of the image as they have been collected by the sensor. But on top of that, providing all that information, all that additional information in a manner which hasn't bloated up your file sizes that you're now having to move throughout your workflow.
Right. And
So, you know,
I see that the slide you gave an example image there. So IIQ, that image would be about 143 megabytes. If you were to explode that out to TIFF so you could work with it, it's going to be about 865 megabytes. Now, understand, you know, not to brag here a little bit, but we are the first to integrate IIQ into the software workflow. So when you're able to bring in 143 megabyte images versus an 865, it's a lot less size. It's a lot less computing power that's required, and it's a lot less storage space. So yeah, please continue.
And well, basically, you've hit the nail on the head. You know, in terms of when you're you know, we have to accept that in many project environments, you need to move images from, you know, one environment to another environment very efficiently. And you know, we want our users using Simactive software to be able to take our images in the most efficient way, to be able to use in all of the great routines that Simactive has to enable you know, your customers to be able to get the best products out from using the best camera, right? So you know, anything we can do to help facilitate you being able to use the most amount of information from the image that you can do in your normal processing in the most efficient step is always going to be a good thing. And don't forget, you know, as soon as you start translating the native format of a camera into a third-party format, you are doing things to that image. You know, not only is, you know, your TIFF, you know, 6 times bigger than what your IQ is in this scenario. You know, you have applied computational processes to that image to make the TIFF. Equally, you know, if we talk about another, you know, frequently used, you know, third-party, dare I say, open-type format, as frequently used JPEG, you know, you are applying compression routines. So again, you're going to be applying routines across the image, which compress the image in all sorts of places across the image, and so you're now not getting all of the information in further down the workflow. So if we can reduce the number of steps, the number of changes we have to apply to the original image, it means that when you're using the image further down the workflow through Simactive, for example, then you're using the data as it was captured.
Yeah, and kudos to the team at Phase One, because they know this and they've put together and opened up the SDK for everybody to incorporate this. Because honestly, at this point or prior to this, the workflow would be you capture the images, their IIQ. At some point, when you go to process images, you're going to have to explode those out to a TIFF format or a format that software can read, which the first thing you start thinking about when you're running big projects, and this is where we get it from our clients. We have clients that capture, you know, thousands and thousands, tens and 20,000s of images. You know, to go from an IIQ format and file size to a TIFF, which is, you know, roughly 6 to 8x, first thing you gotta go look at is how much storage space do I have to even do this? And second, you don't want to do that until you're right at the point of processing, because to try to manage moving those across networks is crazy. So the fact that you guys provided this SDK and we were able to jump on it and build it into Correlator3D is for our bigger clients. And I'm telling you right now, if you're listening to me, you're going to be a bigger client someday. You may be starting off in the drone world, but when you get good and known, you're going to start to realize that there are other places I can do this work, and you can get into this larger production world. And it's you know, it's a great place to be. And thanks to our friends at Phase One and folks at Planix and all these other, you know, that are building these systems, we've got a great market for people to work with these things. So on the IIQ format, again, you talked about how JPEG, you know, even though it's a lossless compression, it's still taking things out of the image. And in reality, you want to keep everything in the image that you can, because that is something that is exploitable. And I always go back to, you know, again, back before we had computers and we read books, and they talked about photogrammetry. Your flight hours were between 10 and 2, or whatever the sun angle happened to be for that time of day. With with the ability to capture all that information and keep it in raw, like you said, you can now see in shadows, or at least see a lot better in shadows. And when you think about it from a software standpoint, from looks like something like Correlator3D, that means that when we're collecting tie points for these bundle adjustments, the software is going to be able to find more of these tie points, which will create that tighter bundle adjustment, which is why you want to be in this space with these higher quality systems.
Well, that's exactly the type of efficiencies that the combination of both preserving the characteristics of the image as captured. Now we use a certain type of CMOS sensor to be able to preserve the radiometric resolution of the image in those dark areas, for example. You know, we want to maintain the information, as much information in the image as possible. So, and the reason for that, and the reason for that is that you're quite right. When it comes to standard photogrammetric techniques, which you need to apply to generate your wide area mapping type products, it's better to see tie points across an image, regardless of what the lighting angles are and that sort of thing across, especially across wide area mapping projects and that sort of thing. You're saving project time. And all of this, which we're talking about, is about saving project time. That's your investment in equipment and software and that sort of thing. That's relatively small in the general scheme of things when you start talking about project time.
Yeah.
And that's how your processes work by reducing the sources of error, by reducing time to have to go looking for things, to better transfer images from one place to another. This in professional workflows, it's these types of things which we're trying to optimize.
Yeah. Again, there's a cost to that too. I mean, network equipment is expensive, storage space is expensive. Not super expensive, but still, if it takes you a sixth of the storage space to manage a project, you're going to have a lot less hard drives laying around. So anything we can do as a equipment provider or a software provider to be able to work with images in raw format, in reduced size, that makes it easier for all of us. And again, even though I'm talking about large projects, if you're the guy out there with your inspection unit on a 300, that means you can have this on your laptop versus having to carry a big workstation with you. So it means something. It really means something.
It translates at all scales, and Eric, especially by your job title, sir, workflow is everything.
Yeah.
And anything you can all do to optimize workflow, that's where it's at.
Yep. So I had one item in there that talked about when to use IIQ, and this was kind of a trick question for people. If your software can process IIQ data, use it.
Yes.
That's the reality of it. If your software cannot process IIQ, then you're going to have to decompress the data, which is fine. It's just a workflow step, and it's not so bad, especially when you're working with smaller projects. When you're working with bigger projects, you're probably going to have to subset your bigger project and be able to work with it that way. So, if your software doesn't process IIQ, get on those people and get them to integrate that SDK. But again, I would say, and this again comes from our clients above us who say, hey, we got 50,000 images. We got, and we can't sit here and subset this project to do what we need to do. So, we gave them distributed processing on our side, on the software side. So that helped quite a bit. Now we're giving them this IIQ integration. So that will make life easier for everybody as well.
If you don't have to spend your time converting data formats, what is that going to do for you?
Yeah.
Pure and simple. You want that data to go from point A to point B in the fewest number of steps.
Yeah, exactly. So, and that, the slide was up on the aerial workflow, and again, you are partnered up. You have flight planning software for the people. You have the export out to IIQ with the information you need for the images. So it is at that point, it becomes an image data set, which you should be able to bring in and process in whatever software you're using. With that, really, I think now it's time to get into the little bit demonstration part with Thomas. Thomas, Will and I have been chatting away, and now we're to the point where it's demo time. So let's actually get into this. Let me go ahead and share the screen so that you can show everybody how we integrated IIQ into the software. Let me share.
Sure.
Yep, you're in charge. Go ahead.
Awesome. Thank you, Eric. Screen number 2 and share. So just let me know, Eric, when you guys can see my screen so I can start the demo.
There you go. We're good.
Awesome. Thank you. So I'll just go over how to create a phase 1 IIQ project, and then I'll probably just go over the few different modules just to show the workflow. So the first thing is that when you use IIQs, well, as you guys mentioned previously, you won't have to do the conversion. So this will save quite some time, especially if you are dealing with a few hundred or thousands of the IIQ image. And then it's going to save a lot of disk space. So being able to support and to create the project straight from the IIQ has these two advantages. You save space and you avoid converting the image. So what you see here on my screen is a project that has been shared by Phase 1. Thanks again, Phase 1, for sharing this data. This is from Seattle. It's in the region of the Space Needle. So we have a few IIQs there. Let me show you how you can create the project first using the IIQs. So you go either into File, Create a new project, or you can use the big icons that you have on the top right here by clicking the first one to create a new project. So when you create a new project, as usual, you select the type of image, I mean the size of the image, because UAV will be for image up to 50 megapixels. Medium will be up to 100, and then anything larger than 100 will fall into the large format. What I have here today is image coming from the PAS 280. So we have images that are 280 megapixels. So I'll click on the second option here. And the number of cameras, I'm going to leave this to 1. Of course, the PAS 280 can shoot obliques and nadir. In my case, for today's demo, I'll only take the nadir images. So I'll leave the number of cameras to 1. But if you have like all of the oblique sensors, you can maybe add a few more image, front, back, and so on.
Right.
Left, right, and nadir. So I'm going to leave this to 1. I'll just type nadir here and then click on next. Now image selection. This is where you want to go and get your IIQ image. So if we go into image IIQ folder, nadir, there you have all the IIQ image. So I'll click on open. This will load the IIQs. Of course, we support the metadata, the EXIF. All the information, the EO information we have within the IIQs. So you don't have to do anything here. In case you guys post-process your EOs, you always have the option to load an external file here to get your post-processed EOs, which is not my case here. I don't have to touch anything there. I click on add. Next window will be the projection system selection. So as usual, you can either leave the default projection system or use any custom EPSG code or like the projection system you want to use for your project.
Right.
Here we see that we have loaded 96 images. We see the dimension of the image. So I just like quickly scroll down my image. I see that everything is fine. My projection system is right, so I can click on next. Next window will be the camera parameters. So just look at your camera calibration report. Double check the values here. If you have some radial or decentering parameters, distortion parameters, you can add these values here. And always good to remember that once you have entered all your camera parameters, you won't have to do this each time you process a new project. You can save a cam file and then click on import. Next time you create a project using the same sensor, you'll click on import and then just fill up all the values automatically using your camera calibration file. So I'm going to click on next here, last window of the project creation. So as you can see, this is very similar to creating a project using either TIFF or JPEGs. We didn't change anything in the project creation, except that instead of loading TIFF, you will be loading the raw IIQ files. One quick comment on the project folder. You want to be sure that you pick a disk where you have enough storage space, because if you were processing a very large project with a few hundred or 1,000 images, you don't want to fill up the disk. So be sure that you use a disk where you have enough space for all the outputs, the orthos, the DSMs, and so on.
Right.
And also, if you have the option to use an SSD drive, this will greatly reduce the timings, because we really benefits, like our algorithm have been revamped to take benefits of the SSD technology. So I'm not going to recreate this project because I've done it before. So let me show you how it looks like when you create the project. Well, you won't see the mosaic. You'll just see some background images, background base map, and then your flight lines and the center of each image. Another good advantage of using the IIQ is that you will guarantee that you do not reduce the number of bits per image. You know, sometimes when you do the conversion from IIQ, so in my case, if you look here in the layer tree and look at one image, if we scroll down into the properties, we'll see that the bit depth of the IIQs is 16 bits. Whereas sometimes when you do the conversion, you do not preserve the same range, and then you will reduce this range to 8 bits. So when we talk about bits in an image, it's like shades per channel. So if you're dealing with RGB, in my case, I'm dealing with 3 bands, 3 spectral bands images, so red, green, blue. If you have 8 bits, that means you will have a range of 0 to 255 shades per channel. So 0 to 255 options for the red, same for the green, and same for the blue. Whereas when you're dealing with 16 bits images, this will increase the range from 0 to 65,535 shades per channel. And just to show you how these are numbers, but if we look at a preview of one of the 16 bits image, you see the range of colors we have here. This roof here looks a bit white, but if I scroll down, we stretch the image to the bits. So let me show you when we get very close to the roof. You see it becomes way darker. We see way more details. So now we're profiting from all the bits, the 16 bits per channel from the image. And how is this useful? When you run the tie point extraction, for instance, so when you try to connect the image, trying to find similar features from all the surrounding image, by using these 65,000 shades per channel, you will have way more options to attach the image and to identify similar features from the image. So this is another advantage of using the IIQs. You guarantee that you keep all the bits per channel, the intensity you have from your images.
So let me stop you there. So the reality is that if you've got that kind of range versus the 8-bit, when you're looking at that roof, what would normally appear white, you have a lot more information for the software to create those type points, which means that the surface that it builds over that rooftop is going to be much more accurate. So
Exactly.
excellent representation, excellent way to show that to folks. I really think that's great, Thomas.
Yeah, it's always better to like, I mean, it's always easier when you look at the image and then see when we stretch the image, way easier to understand the concept behind. So
Great.
that means when you run, so once you have created the project with your IIQs, and as you can see the layer tree, instead of TIFF here, we see that we're dealing with the IIQs. Even if the IIQ is a compressed format, it doesn't really slow down. As you can see, if I right click one of the image, the preview pops up like the thumbnails. I can access the image right away. But to be honest, if in reality, if we go like to the details, the IIQ will take a few tens of seconds more time to open because we uncompress in the background, we uncompress the IIQ to get all the raw information from the pixels.
Right.
So when you start processing the image, the first, as usual, the first module you will be using is the aerial triangulation here. So same as for any other project, what we will do is first run the type point extraction. And again, when you're dealing with 16 bits images, it will give way more details for the software. Especially this is very useful in occlusion areas where you have like shadows, where you have like more less spectral
Range.
contrast, I would
Yep.
say. Then by using the 16 bits contrast, I mean shades per channel, this will allow the software to extract way more type points. So this is just to show you what a type point is. When we look at two image, we have like all the type points that have been created. But in reality, if I look at one, if I right click again one of these type points, we'll see that this particular type point is not attached to only one image, but to all the images that are looking at the same feature. So in my case, it would be 7 images. And I think this black image here is just because I unplugged my other hard drive. Sorry about that, guys. Not a big deal. I have my IIQs separated into hard drives, and then the other one is not plugged in. But as you can see, we have 7 images looking at the same feature on the image. It's the center of this block on the roof. So yeah, that's how we can attach the image together. Once the type point extraction has been completed, we see that we have a nice density of type points throughout all the image. Then we can run the bundle adjustment to complete the aerial triangulation. The other thing we have with this project is some GCPs, ground control points. So let me uncheck the links. Here we have one here, and then one, where's the other one? Down there. So let me show you this first one. The ground control point was the angle of a road sign, I think, or yeah, this is a square handicap square on the ground. So the northwest corner has been surveyed very precisely. So you enter you load the GCP file, either a CSV, a text file, or an ASCII file, and then you tag the GCP on the image. And once this has been completed during the bundle adjustment, you will have the option to use the ground control points to refine the accuracy of the project. And this is why when you go through the workflows, you generate the DSM. DSM is quite sharp using the IIQs. As you can see, we have like lots of details on the DSM. Again, I'm not going to spend too much time, but as you guys know, you can edit the DM. So just to show you, we have, you know that in photogrammetry, as water is a moving material, it creates a lot of noise. So just to show you quickly how we can edit, like one of the many tools we have to edit the DM. If I draw a polygon around this body of water, I can draw the polygon and then maybe use the delete and fill option, which is here, or I could even use the set to a given elevation. But when you do this, this will just like flatten the area using the surrounding pixels to interpolate and then get remove the noise. So I'm not going to spend too much time here with DM editing tools because we have a full 1 hour webinar covering this topic. So once the DSM has been generated, you can then extract the DTM from the DSM. So bare ground digital terrain model. Same tools in case you want to edit the DTM to maybe remove some noise or fill up some holes. You have all the options available. And then once the DSM DTM have been generated, you can then ortho rectify. So we have all the orthos here. Let me load them quickly. So ortho rectification, you have two options. You can either ortho rectify over the DSM or over the DTM. So if you want to do a true ortho rectification, this will be an ortho rectification over the DSM. If you want to do a DTM ortho, and you have this option when you click on the ortho rectification module here. You have the option in case you want to do a true ortho, you have to check the DSM based option there. With the phase one, we have very nice true ortho results, especially when you have like such a detailed DSM. It reduces the artifacts you have around the building roofs and so on. Something I'd like to do when I complete my final mosaic and that I'm using GCPs is to scroll all the way, to zoom all the way to my GCP and then check if my mosaic is well sitting on the GCPs. So this guy here is the side of the pedestrian path. I see that my mosaic is very well aligned with my ground control points.
Yep.
One last thing. So most of the time, what I discovered recently when we added this option to support the IIQ is that the color balancing is awesome. So you will probably not have to do any manual color balancing, but we still have the option if you enter into the mosaic editing tool here. You always have the option as for any other project to play with the histogram of each channel, each spectral band. So in case you want to play a bit with the red, you can play with the histogram, the input, min, and max, and you will view the. Let me show you something a bit intense. Play with the gamma, and then maybe darken a lot the mosaic. If you toggle on and off the preview, you will see the difference from the raw images. I mean the raw color balancing and the manual color balancing. So you still have all these options. The histograms, you have like way more, the range of colors is increased because of the 16-bit
right.
per channel that you have with the raw images.
So in general, I mean, we're going to see better results with that 16-bit image than we would say with an 8-bit. Not only in the dynamic range that you can adjust the mosaic, but also in the going back to the AT process where it's finding points in shadows that you typically wouldn't see in an 8-bit image. And
yes,
it also makes me think, okay, now I know why some of our larger customers are headed that way with the phase one, because some of them are doing shoreline work. And yes, you can't map water, but when the water is very shallow, you can certainly see things in water that additional range would pick out and probably create type points in, which is pretty impressive.
Exactly. You'll probably identify a few rocks at the bottom
Yep.
or a few features at the bottom, which will let you integrate this image into your aerial triangulation.
Yeah.
And then even map the shorelines. So yeah, using the IIQs is a great improvement for phase one users.
And then I noticed in the ortho window, and I assume in the mosaic export window, you have the option of exporting out the 16-bit or the 8-bit. Is that correct?
Yeah, exactly.
Yep. Mm-hmm.
So another thing you can do when you have generated the mosaic is to export the mosaic, and you can compress this mosaic because we do not yet offer the option to export the mosaic in an IIQ format. The output format will be a GeoTIFF, but you have the option to compress this GeoTIFF into JPEG in a TIFF compression type, and this will reduce the size of the GeoTIFF by a ratio of approximately 10. So if
Very
the
good.
final GeoTIFF is 10 gigs, the JPEG in a TIFF compression will reduce the size to approximately 1 gig. Which is a nice option when you're dealing with very large areas. Maybe you can also tile final mosaic into I don't know, maybe tiles of 10,000 pixels by 10,000 pixels. So of course, this will depend on the GSD of your image. But tiling this and then using the compression will greatly reduce in case you have to deliver the outputs online or to send them to customers.
Well, perfect. That's a great demonstration of the process in Correlator3D, how we work with IIQs. Really, it's very smooth and integrated, knowing that you're working with a data set that's greatly compressed as an IIQ makes life easier for you. The 16-bit versus 8-bit, that's, to me personally, that's huge. It really helps you create better results. So that's awesome as well. And the last thing that I can say personally is that I'm extremely jealous because I just found out that Thomas gets to go see the Tour de France, which is a dream of mine. So lucky dog. So with that, we'll finish off the demo portion and close out the webinar. Again, if you had a question and we didn't get to you, we will respond via email, and you're always welcome to reach out to us. Thanks again, Thomas. Appreciate it.
Thank you, Eric. Thanks, everyone.
Cool. I'd like to thank my guest, Will Tompkinson from Phase 1. We really appreciate you being on the line.
It's been an absolute pleasure. We most enjoy being able to share what we're doing with our partners and really helping the community understand how to get the workflow better.
Thank you, everybody. If you enjoyed this webinar, if you enjoy the podcast later on when it's created, let everybody know on social media, and look forward to talking to you all later. Thank you.